Hello children, I welcome you all once again. I hope you all are in good health and doing your studies regularly. Dear children, today we shall discuss the chapter 11, which is on force and pressure. You all must have used these words force and pressure very often. So, in this chapter, let us try to understand what this force and pressure is all about. Let us try to understand the concept of force first. Let us consider a day-to-day activity. What is happening here? A man is pulling a cart, isn't it? A pull is a force to make the cart move towards him. So, we say the man is exerting a force on the cart. Now, consider another situation. Here, a man is pushing a box. A push is a force. The person is exerting a force on the box to make it move away from him. Consider yet another situation. A person is pulling a box. A person pulling a box is also applying a force. The person is exerting a force on the box to make it move towards him. So, children, after going through these examples, can we define what is force? Yes, you are right. Force is a push or a pull. Let us consider another situation. Two persons applying some force. There are two persons, A and B. Both are applying force. Who is pushing and who is pulling? And why? Let us take another situation. Who is pushing the box and who is pulling the box? And why do you say so? Will the box move in such a situation? If it moves, when will it move? When will a force come into play? When two objects attempt to change each other, there is said to be an interaction between them. Consider this situation when a boy is pushing a wheelbarrow. The boy is exerting a push on the wheelbarrow and the wheelbarrow is opposing the push exerted by the boy. Now, there is an interaction between the two. A force will come into play only when at least two objects exert force on each other. This is an interaction between the boy and the wheelbarrow. If there is no interaction between the two, there will be no force. When a ball strikes a wall, there will be an interaction between the ball and the wall. Therefore, force comes into play. The ball pushes the wall and the wall pushes the ball in the opposite directions. Each of these forces will attempt to change the direction of the ball. Let us consider one more example. Consider a fruit falling from a tree. While it is falling, which are the two objects which are interacting? Here, the interacting objects are the fruit and the earth. The earth pulls the fruit towards it and the fruit also pulls the earth towards it. So, after seeing all these examples, let us now try to define force again. Force is a push or pull from one object to another. A force arises only when there is an interaction between the two objects. When the interaction ceases, the force also disappears. Now, you can open your textbook and go to the table 11.1 and complete the table with your response. As we know that every physical quantity has to be associated with a certain unit. So, what is the unit of force? Let us see. Like the unit of length or distance is meter, the unit of mass is kilogram. The unit of force is called as Newton. Its symbol is capital N. To fully describe force acting upon an object, you must describe both the magnitude, that is the size or the numerical value, and the direction. So, force has both magnitude and direction. How to represent a force so that its magnitude and direction both are represented? A force is represented by a straight line with an arrowhead. The length of the line is proportional to the strength, that is the magnitude of the force. The arrowhead represents the direction of the force. Let us say we need to represent a force of 1 Newton acting due west. How to represent this? So, we have to choose a scale. Let us say a line of length 1 centimeter represents 1 Newton of force. So, we have to draw a line of length 1 centimeter along east-west. The arrow on this line should be such that it shows the direction. So, the arrow should point west. This is how we represent quantities which are having a direction as well as magnitude. What happens if more than one force acts on an object in the same direction? Consider a trolley being pushed in the same direction by two kids. The girl is pushing with a force of, let us say, 3 newtons, and the boy is pushing the trolley with a force of, let us say, 7 newtons. Now, the trolley experiences a bigger push. Since the two forces are acting in the same direction, the magnitude of the two forces gets added up. The magnitude of the total force will be equal to the sum of the magnitudes of the two forces. The direction of the combination of force does not change. So, we see that the forces have added up and the resultant force is greater than the forces applied individually. Let us consider another similar situation. Two boys are pushing a box in a direction. Let us say they exert a force of 2 newtons each. What will be the net magnitude of the force on the box? Yes, you are correct. The net force acting will be 2 newtons plus 2 newtons is equal to 4 newton. In our previous examples, both the forces were acting in the same direction. What will happen if the forces are not in the same direction, but are acting in different or let us say opposite directions? To understand this, let us take another small example. We shall consider the tug of war situation. Who will win this tug of war? Yes, you are right. Definitely the side that pulls with a bigger or a greater force. If a force, let us say, of 20 newtons is acting on an object and another force of 50 newtons is acting on the same object in the opposite direction, what is the net force acting on the object? Yes, you are right again. The net force is 50 newtons minus 20 newtons, that is 30 newton, and the net force will be in the direction of the bigger force. So, let us take one more short example. If like in the previous case, now the boys are exerting force of 2 Newton each on the box in the opposite direction, what will be the net force on the object? Yes, you are right again. The net force will be 2 Newton minus 2 Newton, that is 0. So, children, we saw that the forces add up as per their directions. If the forces are acting in the same direction, they add up and the resultant force is in the direction of the forces applied. Whereas, if the forces are acting in the opposite direction, then the resultant force is smaller than each of the forces, but will act along the direction of the larger force. It may also happen that force is applied on the body, but still the resultant force on the body is 0, and that happens when the forces are applied are equal and opposite in direction. Though we cannot see a force, but we can always say what effect does it have when it acts on a body. What can a force do to a body? What is the effect of force on a body? Let us explore. Let me push this book lying on the table. It moves. The force I exerted on the book caused its motion. A wheelbarrow at rest can be made to move by exerting a force on it. We may say that a force can make an object move from its rest position. Children, can you find some more examples where force is applied on a body and it causes some changes? Surely you can. There are numerous examples around you. So, we can see that force makes an object move. What else can force do? Can force change the speed of an object? Yes, force can also increase or decrease the speed of a moving object. We see all around us many situations where force brings a moving object to rest or makes an object in rest move. That means force is changing the speed of the object. In a cricket match, a batsman hitting the ball will change the direction of the motion of the ball by applying force on it. So, a force can change the direction of motion of the object. Is that all a force can do? Is there any other changes force can bring about? When we apply a force on a rubber ball with our hand, the ball gets squeezed. The shape of the ball changes with the application of force. We change the shape of dough while making chapati by applying force. You must have seen this many times in the kitchen. A potter, while making pot with clay, also changes the shape of the clay by applying force with his fingers. Can you think of more situations where force changes the shape of the object? So, a force is very much required to change the shape of an object. So, let us now summarize what are the effects of force. A force can move a stationary object, a force can stop a moving body, a force can change the speed of a moving body, a force can change the direction of a moving body, a force can change the size and shape of a body. I think now you must have understood what are the effects of force, what all things the force can do when it is applied on an object. Now, we shall try to understand different types of forces. Based on the way of interactions occur, forces are broadly classified into two types: interaction by contact and interactions at a distance. To move an object by pushing or pulling it, our body must be in physical contact with the object. Otherwise, it is impossible to use our muscular force to make it move. Muscular force and frictional force come in the category of contact forces. But is it necessary that all the forces come into play only when there is a contact? Yes, there are some forces which even come into play when there is no physical contact between the two interacting bodies. Such forces are called as non-contact forces. The forces in such situations act from a distance. A fruit falling down from a tree is caused by a non-contact force. You all know this is called as the gravitational force. This force will come into play between two objects even when they are not in contact with each other. This is action at a distance. There are other forces which act from a distance. We shall learn more about these forces in the coming lessons. So, children, let us summarize what all things we have learnt in this video. We learned that force is a push or pull. Force arises due to interaction between objects. Force has both magnitude and direction. We need to mention both magnitude and direction to completely describe a force. Force is represented by a straight line with an arrow overhead. The commonly used unit of force, which is the SI unit, is Newton. We also learned that force can change the state of rest of an object, speed of an object, direction of motion of an object, and the shape and size of an object. We also learned that some forces come into play only when the interacting objects are in physical contact with each other. Such forces are called as contact forces. Some forces come into play even when the interacting objects are not in physical contact with each other. Such forces are called as non-contact forces. They act from a distance. Well, children, this is all what we have in this part of this video. I hope you all have understood what is force and what changes a force can bring about. In the next series of the videos of this chapter, we will have a detailed explanation of the different types of forces. Till then, take care of yourself, keep learning, keep in good health. Thank you.